There were two homework questions about section 11.6, so let's see what we can do with those. The first one gives us a circle. They tell us the entire area is 60 pi. They tell us there's an arc that has an area of 24 pi. So we get a 60 pi and we get a 24 pi. We want to find the measure of an arc. Now, we haven't really talked a lot about arcs of circles. Unfortunately, chapter 10, the circles chapter, is the chapter that we're not quite going to get to as much as we should. But basically, an angle of a circle, a central angle of a circle, a sector has an angle measure that's up to 300 degrees. You can also say that the arc on the outside has the same measure as the central angle. So for example, if I had a 60-degree central angle here coming from the center of the circle, we could also say that's a 60-degree arc, okay? So really, we just want to find the angle measure of that arc, okay? This is just a backwards version of the problems we've been doing. Remember, we've been taking a fractional part of the area of the circle, and that tells us the area of a sector. Now we've got the area of the sector, and we've got the area of the whole circle. We can find the fractional part of the circle we have, and we just want to figure out what fractional part of the 360 degrees of the circle is that, okay? So it's pretty much the same type of setup. It's just kind of in reverse, okay? So we still have this part to whole setup that we've been doing over and over again, problem after problem. But this time it's an area of 24 pi compared to a whole area of 60 pi. Okay, now I would simplify your fraction down just to make things easier to do. We can divide pi out of the numerator and denominator. We can divide both of these by 12. 24 divided by 12 is 2. 60 divided by 12 is 5. So the angle we're looking at is supposed to be 2/5 of the entire circle. In other words, 2/5 of 360 degrees. And as we know from 5th or 6th grade, if you take a fractional part of something, that word of suggests that you're going to multiply. You multiply 360 by that fraction, okay? So you can multiply 2 times 360 and then divide by 5. I actually know that 5 goes into 360 72 times. 72 times 2 is 144. So however you want to work that out. But in the end, that means this is a 144-degree sector. It's about 2/5 of the circle, so actually a little bigger than what I drew there. And we can also say that this arc here is 144 degrees of the total circle, okay? If you're going to find the actual length of that, you could take 2/5 and you could multiply it by the circumference of the circle, and you could find that, although they didn't ask that here, so we don't have to worry about that. All right, number 14. I was asked about part E. They asked me for the shaded area here. We have a square that is inscribed in a circle, and that just means that the vertices of the square touch the edges of the circle, okay? So for this problem, a lot of times I'll write a little statement stating what I need to do here. I really need to find the area of the entire circle, and then I'm cutting out that square. So I'm taking the circle area and I'm subtracting the square area. That's really what's happening, okay? So a lot of times I'll write a little phrase in words, and those are the things that I need to find and what I need to do with them. All right, so the square area is going to be pretty easy, right? Because that's a 10 by 10 square. So the area of the square, 10 times 10 is 100. That's what we're going to be removing from the circle. The circle, we know the area of a circle is equal to pi times the radius squared. We don't have the radius here. However, we know from the right triangles chapter that if you cut a square in half, you get a little 45, 45, 90 triangle. We know for a 45, 90 triangle that the side lengths are x, x, and x radical 2. So the diameter is going to be 10 radical 2. That means that the radius is going to be half of that. It's going to be 5 radical 2. Okay, so the area is going to be pi times the radius of 5 radical 2 squared. Okay, 5 times 5 is 25. Radical 2 times radical 2 is radical 4, which is 2. So 25 times 2 is 50. 50 pi square units, so a little bit more than 150 square units, is the area of that entire circle. Okay, so we can write this as 50 pi minus 100. I don't think the question says to round, so leave it in exact form. And again, these are not like terms. This is 50 pi's, this is 100 ones. That's as simplified as it's going to get. You could say 50 pi minus 100 square units. Might be good to put units in there. But otherwise, that's all that's going on there. So hope that helped.